Hello everyone. Today I would like to share my insights on how the different dynamics of the pandemic, of the COVID-19 pandemic in different parts of the world is ultimately going to lead to the same outcome. That is at least my view based on my scientific insights. So, as we all know, in some countries, the mass vaccination campaigns seem to be a very big success. We know, for example, in countries like United Kingdom and Israel, infection rates have been going down quite dramatically. And this is seen as a success by health authorities and stakeholders of these mass vaccination campaigns. Whereas in other countries, where to some extent vaccine coverage rates are maybe not similar, but pretty close, like for example in Chile, I think Chile vaccinated right now approximately 40% of the population, one dose, compared to the UK 50%. And there, on the contrary, the infectivity rates are going up. So that is a pretty stunning finding, observation, and it's, I think, too often explained by authorities, being due to the lack of adherence to infection prevention measures or people traveling, etc. So very often young people are blamed for not respecting well enough the containment measures and social distancing and wearing masks, etc., or traveling. Whereas I personally think that at this point in time, where we have infectious variants proliferating all over the world with high infectivity rates, and the virus being almost like everywhere in all neighborhoods and in all families, I'm pretty much convinced that at this very moment in time, the effect of infection prevention measures becomes increasingly diminished, and that essentially the factors that are of key importance are, of course, circulation of variants, also the speed at which we vaccinate the population, and of course also at which time point do we vaccinate the population. So before I show you my forecast, what I think is going to happen, I think it's important to point out a number of things. First of all, I would like to remind you that when one talks about population dynamics of a pandemic, it's important to realize that we are in fact considering a phenomenon that I'm calling collective immunity. Collective immunity is built or generated as well by natural infection, of course, and also in this pandemic by mass vaccination. And collective immunity has a substantial impact on, a substantial impact on immune selection pressure. So it puts a substantial, because it's collective immunity, it's really the immunity of the population, it puts a substantial pressure on the virus and on the whole viral ecosystem of this pandemic. And by doing so, it can enhance, in fact, the adaptation of the virus to certain suboptimal immune pressure circumstances. So that is one thing to bear in mind. The second thing to bear in mind is that as we continue or as we intensify the mass vaccination campaigns, we have to realize that the infection increasingly occurs amongst the non-symptomatic people, so the asymptomatic people. So this is simply because the vaccines are still pretty good at preventing disease, especially severe disease. So it's logical that the infectious event now primarily occurs amongst asymptomatic people. So these asymptomatic people are as well people that have been vaccinated, of course, and that can also spread the virus, although it's very clear that the infectious load or the shedding will be dramatically diminished when you're vaccinated, but nevertheless, especially when they encounter variants, so that have a spike protein which is pretty different from the S protein in the vaccine, they are still able to shed virus. So this is one part of the asymptomatic population, asymptomatically infected population, and that can spread virus. And the other, of course, are people who are not vaccinated but are naturally infected in an asymptomatic way. So what is the difference? Well, people who are asymptomatically infected, so by natural infection, a lot of them, not all, but a lot of them will build a kind of immature immune response to the S protein. So that means they are building antibody titers against S protein that are not completely functional, very often lower titers or short-lived antibody titers. And those are primarily directed against the S protein and put pressure on the infectivity of the virus. So they are directed basically against a number of different sites on S protein, not specifically directed at the receptor binding domain. And then, of course, you have the asymptomatic vaccinated people who are, of course, mounting antibodies against primarily the receptor binding domain, and in this way also putting immune pressure on the virus. So the third thing that is important to realize is that within this population of asymptomatic people, we have a lot of suboptimal immune conditions. So a lot of these people find themselves in a suboptimal immune status. So why is this? Well, I already explained that people who are asymptomatically infected by natural infection develop often, but not always, but oftentimes immune responses that are not really fully mature and full-fledged. So suboptimal in a way and poorly functional. Whereas people who get vaccinated, of course, when they get vaccinated, they take time to mount an immune response. And for example, some of these people are waiting for their second dose. They are confronted with variants. The antigenic constellation of the S protein of those variants can be different from the antigenic constellation of the S protein in the vaccine. So that also makes their immune response to some extent suboptimal. So this is important to realize because in order for a virus to adapt to a situation, to immune pressure or any kind of pressure, unfavorable circumstances, it's important that you can passage the virus, I would say, from one person to another each time under the same conditions. So that requires, of course, that a large amount of the population wherein the virus is circulating is put under the same suboptimal conditions. So, and another factor that is important to consider is that the circulation of infectious variants is also a very important contributor in a sense that it has a great influence on the dynamics of the infection, on the dynamics of the pandemic. And the reason I'm saying this is if you have a high infectivity rate, and that can be due, for example, to the predominant circulation of a highly infectious variant, it is clear that people, for example, who are who were previously asymptomatically infected and are sitting on these suboptimal antibodies, that when they get infected, and the likelihood that they get infected becomes higher when the infectious rate, the infectivity rate increases. So when all of a sudden a highly infectious variant becomes predominant in the population, then of course the infection rate will go up, and the likelihood that somebody who got asymptomatically infected and as a consequence of that has suboptimal antibodies get now re-exposed to this variant becomes increasingly higher. So why is this important? And I've explained this a number of times in previous videos. Well, this is important because if these suboptimal antibodies, they are able to suppress, in fact, the natural antibodies. So this is to say that because they are suboptimal, they are not really very functional, and so they do a poor job in neutralizing the virus, but they can still bind strongly enough to the spike protein to basically put the natural antibodies out of business. And I know there has been a lot of scrutiny around these natural antibodies, but I put a fair amount of literature on my website where it is clear that natural antibodies bind in a completely different way to antigens and to viral particles than do antigen-specific antibodies. That is one thing. The other thing is that it has also been shown that natural antibodies can neutralize and protect against a number of different variants of several different viral species, amongst others also, for example, influenza viruses. And also, even for coronaviruses, it has been shown that natural antibodies can prevent the virus from interacting with ACE2 receptor on the cell. So there is a number of evidence on these natural antibodies and how they interact with virus compared, I would say, to antigen-specific antibodies. So when this happens, of course, when natural antibodies due to competition are put out of business or to some extent, then this suppresses the innate immune response of those subjects. And because it suppresses the innate immune response, these subjects become now all of a sudden more susceptible. So this is to say to the disease. So this is to say, in fact, that subjects which have a relatively low concentration in natural antibodies, they will not be able to resist that infection with the highly infectious variant. And so all of a sudden, you will have a huge wave of disease. It will also affect younger people, and those are the people who primarily have high concentrations of natural antibodies. But when, in fact, this capacity of people with relatively low concentration in natural antibodies gets exhausted, then also all of a sudden the wave of disease will stop. So that is what I'm trying to depict in this slide, where you see, so this is the capacity, the total capacity of asymptomatically infected people. So these are the people that have been resisting the first infection and that have built antibodies, to some extent antibodies that are not fully functional. So when now due to high infectious pressure, for example, the selection of an infectious variant that starts to dominate in the viral population, then due to the competition between the specific antibodies and the natural antibodies in those people, you will have a suppression of the innate immune response. So that is to say that part of these people now will no longer be able to resist this infection and will be susceptible to the disease. Those that remain still have natural antibody titers that are high enough to resist, and when this capacity is exhausted, all of a sudden the wave of the disease will dramatically stop. So let's assume there is no vaccination involved. So when now, for example, the virus would need to continue to propagate in this population, despite the fact that in fact the reservoir of susceptible people got exhausted and that the remaining people still have a concentration of natural antibodies that is high enough to resist the infection, the only way this can happen is in fact by adaptation of the virus to this immune pressure that exists in people who have still elevated concentrations of natural antibodies. How can this happen? Well, as I was saying, this population can represent a substantial amount of people, of course. We should not forget that in most populations, 60 to 80% of people get asymptomatically infected. So in many of them, the antibody titers are suboptimal for the reasons I explained. So you have suboptimal conditions, you have a quite important substantial population. So the only way now for the virus to adapt to this or to overcome this pressure is to select mutations that enable a higher infectivity, a higher infectiousness. Because if mutants that spontaneously occur with a higher infectiousness are selected and adapted to this population, that means that they can bind much stronger to the S protein. And that means higher infectiousness. And when they bind much stronger to the S protein, they can better outcompete natural antibodies. So they can take another part of this yellow reservoir provided adaptation takes place. So that is how, once the infection and the wave of disease has more or less stopped, but the virus continues to circulate in that population, a large population, still with suboptimal immunity, it can adapt, it can select immune escapants that are, have higher infectiousness, it can adapt to that population, and it can overcome, let's say, the barrier of infectivity in the sense that it becomes more infectious, binds stronger to S protein, and can better outcompete. And so the wave of infectivity can again continue once these escape variants have developed and are well established in the population. So let's now maybe have a look at what does that mean in terms of the curves that we are seeing. And I've taken a number of specific or remarkable examples, kind of extreme examples. And the purpose really is to confront my interpretation with the interpretation of the health authorities and the WHO, to see whether we come to the same conclusion and the same outcome. And as I pointed out already, of course, the health authorities, WHO, they think that ultimately these mass vaccination campaigns are going to generate herd immunity and will also control these infectious variants, the multiple infectious variants that are currently circulating. So as you will see, my conclusion will be slightly different. So let's first have a look, for example, at the curves of India and Chile. So India is in yellow and Chile is in black. So, and here is the time point where the mass vaccination campaigns got rolled out, started, and brought up to speed. So you can see, for example, that in Chile, it takes a long time before you see any effect. Well, on these curves, you still don't see a decrease in infectivity. And the same occurs in India. So now people are saying, well, this is normal because, you know, it takes time for the vaccinations to occur. People are not always adherent to the stringent protocols related to infection prevention, etc. So it takes time before we are going to see an effect of the vaccination. Low mass vaccination rates apply, certainly for India, much less, of course, for Chile. I just mentioned that approximately 40% of the Chilean population has received at least one vaccination. So what I can tell you is that in contrast to the very slow development of the effect of the vaccine, which isn't seen yet on these curves, I bet that once the plateau here is reached, and it seems like this is the case in Chile, not yet in India, it will probably still increase, you will have a very steep decrease and decline of these curves. And that is exactly what I was saying. This, in my humble opinion, is simply due to the fact that you started vaccinating, and we know that in Chile, for example, you had the Brazilian variant circulating. Due to the start of the mass vaccination campaign, I cannot prove this, but I strongly believe that this has contributed to favoring the highly infectious variant. Because the highly infectious variant, again, the S protein is more different from the S protein in the vaccine compared to the original strain or to variants with lower infectivity. So when you start then immunizing this population, you will, of course, favor the propagation of the highly infectious variant with a pretty different S protein. So, but once this is the case, so remember, high infectivity rates, they will make sure that a high or a substantial amount of people who got previously asymptomatically infected get their antibodies, their natural antibodies, suppressed. And by doing this, by putting down this level of susceptibility quite dramatically, all of a sudden, you open up an important, a substantial amount of the population to the viral infection. But then, when this happens and when this level is achieved and reached, then it suddenly stops, as I have been showing you in the previous in the previous picture. So, but I can tell you, if this will go down quite dramatically, then authorities will say, see, this is the effect of the vaccination. So that doesn't seem very logical to me. It takes a very long time to start. But then all of a sudden, and I will show you, because this is typically what happened in the UK, it will go down pretty dramatically. And then all of a sudden people will say, well, this is the effect of the vaccine. And so it seems then, according to authorities, that you need a certain threshold, and then all of a sudden the effect of the vaccines becomes very, very remarkable. But that threshold seems to be different in all kinds of different populations, and people say, well, this is due to the different demographics, this is due to the fact that the rate of vaccination is different, and also to the fact that people behave differently. In Chile, they stick less to the rules than in other countries, for example, which I think is not true. The problem with this adherence to infection prevention measures is the same everywhere. So what I was saying is that, as you can see in the next slide here, that is typically what we have seen. We compare Chile here in yellow to the UK. The UK started mass vaccination campaign at the very top of the infectious wave. So at the summit, basically, of the infectious wave. Here, when it reaches the summit, as I was telling, it has to go down because you have a huge wave of infection, a large population, primarily also of younger age groups. Their antibodies are outcompeted, their natural antibodies. When this capacity is exhausted, then all of a sudden it stops. And that is what is happening here, because how can you also otherwise explain that in Chile and in India it takes like an awful amount of time, and especially in Chile where the vaccination rates are quite similar, they are 10% lower than in the UK, whereas here, when you vaccinate in the UK, it has an immediate effect. So that is one thing. The other thing is also when you look at the propagation of the highly infectious variants, when you start the mass vaccination campaign, this propagation and the contribution of the highly infectious variant dramatically increases. It starts dominating within just very, very, very little time, which also seems to indicate that by doing this immunization, you favor, so to say, the escape of the most infectious variant so that it can become predominant in no time within the population. So when we then look, for example, at another interesting comparison, I think, is between the United States and Belgium. Belgium, not because it is my country, but because this comparison, I think, makes sense in a sense that in both countries you had 3 waves. You see Belgium is in yellow and the US is in black. You had 3 waves, and for example, the vaccination started here. Again, in the US, it started almost at the summit of the infectious wave. What you saw is similar to in the UK, an immediate decline, which, you know, for me is not due to the vaccination, but again to the same phenomenon that I just explained. So in Belgium, for example, you didn't start vaccination at the summit of the infectious wave. We were more or less at the plateau. And see, it takes a lot of time, in contrast to the situation in the US. And then, even then, it doesn't go down, it goes up. What we have seen in Belgium, we had the UK variant, which was predominant, is that during this time, the circulation of the UK strain became increasingly predominant. So you have like a higher infectious strain that is now having a competitive advantage, so to say, which can of course be responsible for raising the infectivity rate. So, and now again you reach a kind of summit and then it goes down. Again, the same effect as here, most likely simply due to the fact that you had younger people. That's also what we have seen, that became susceptible. And again, once this capacity is exhausted, because the remainder still has enough natural antibodies that are not outcompeted, you get a kind of plateau. So what is happening here, that is also interesting. In Belgium, for example, you have 15% of the population that got one single shot of the vaccination. And all the others are still non-vaccinated. So what this means is that, in fact, if the virus is now primarily propagating in this population of asymptomatically infected people or asymptomatic people, and that is what I previously explained, because the vaccines are still effective against the disease, so the virus is more circulating in asymptomatic people, the biggest part of whom are non-vaccinated people. So as I say, the non-vaccinated asymptomatic people are those who, to a large extent, are sitting on suboptimal antibodies against S protein. So, and there is a vast, this is a vast part of the population. So a vast part of the population where the virus is circulating and that is experiencing suboptimal immune conditions. This is a good breeding ground, of course, for variants that have a higher infectiousness, because all what the virus here needs to do is just to overcome the overall pressure against the S protein, because that prevents it from being infectious enough. If it can do this, variants will be selected that have a higher infectiousness. Due to this higher infectiousness, again, they will be able to outcompete the natural antibodies in a larger part of this population. And again, this will lead, first of all, to an increase in infectivity, and then it will go down rapidly and stop. But basically, you will have here in Belgium, that is my forecast,
a kind of plateau where maybe you have still a little peak that goes up and then down, but then as more and more people become vaccinated, you shift more or less to the situation that is prevalent right now in the US, where you see you have 35%, in contrast to 15% of the population that got already vaccinated. So the more people you have vaccinated here, the more the virus, in order to be able to propagate, will need to overcome the pressure that is put on the virus by the vaccine. And that pressure comes from antibodies that are specifically directed against the receptor binding domain. So there, the more people you vaccinate, the more the virus will circulate also in that population, and the more, and the conditions are suboptimal, as I was saying, people are still getting vaccinated, one shot, etc. So this will be a good breeding ground for viral mutants that are capable of overcoming the pressure against the receptor binding domain. And the more extreme situation is, of course, what we see in Israel and the UK, where, again, what you can see, both countries were vaccinated or started vaccination campaigns at the very height of the infectious wave. And here, so to say, the effect of the vaccine was immediate. Again, I've explained you what I think this is due to, and it is dramatic because it relates to a big chunk of the population, namely all the younger age groups that have natural antibodies, just not high enough to prevent from being completely outcompeted by the S-specific antibodies. So again, when that capacity is exhausted, it kind of like stops. But when this is the case, you see, for example, that in Israel, in yellow, 60% of people got vaccinated. In the United Kingdom, 50%. So that, what I was saying, the virus is still circulating here. In these asymptomatic people, they can of course transmit the virus. They are still continuing vaccinating. So people one dose in the process of seroconversion, a lot of suboptimal conditions. And so the virus will be able to select mutants that are capable in this population to overcome the pressure that is put on the virus. And here in these populations, the pressure put on the virus primarily comes from these vaccinal antibodies that are directed against the receptor binding domain. So what I am expecting, what I'm sure of, unfortunately, is that after this here, you will have a backlash, you will have a rebound effect of a viral mutant that breaks through the vaccine protection. So resistance, in other words, to the vaccine. And I don't need to explain you what that means, basically. And I think it will first occur in the United Kingdom. The reason why I'm saying this is that United Kingdom have they have 50% of one single vaccination. In Israel, for example, 60% of the population has had not only one vaccine but two vaccines, so the full regimen. Whereas the 50% in the United Kingdom is only one dose. So that means for the virus it's much easier to overcome the pressure put by vaccinal antibodies in people vaccinated in the UK having gotten just one shot than is the case in Israel. So I don't know when this will occur, how much time it will take. I think it will be within the next 2 months. I'm pretty sure that this should occur because things are going with the mass vaccination and by all the events of immune adaptation that in fact are favored by this mass vaccination, it should go relatively fast. So my expectation is certainly within 2 months. So there you see that my perspective, unfortunately, is very different from that of health authorities, because what the health authorities and the national authorities are saying here is look, this is going down pretty fast and pretty dramatically. I mean, we are up for a beer and we can open up everything, because this is the thing that adds to the risk, is that now everything is opening up, for example, like in Israel and quite recently also increasingly in the UK. Precisely that is what I think is not going to happen. So in more or less in conclusion, I think what is a little bit sad in this situation is that we don't have a consensus on the criteria that everyone would accept to say or to judge whether or not mass intervention, mass vaccination or infection prevention measures are having an impact on the change, I would say, of the virus, well, on viral immune escape. So if we could agree on criteria that everybody would say, well, if you see this happening, then we all agree that clearly there is selective immune escape against the S protein, leading to either enhanced infectivity, infectiousness of the virus, or even resistance to the virus. Then, and the definition could also be, well, if you have increasingly variants that select mutations in the S protein, leading to enhanced effectivity, or you even have like mutations primarily located in the receptor binding domain of the virus, which would then of course increasingly lead to a risk of resistance to the vaccine, then we could start really a discussion. But for example, the fact that despite large mass vaccination campaigns and increasing coverage, like for example in Chile, you still don't see any effect of the vaccine. On the contrary, it's still increasing. The infection rate and mortality in disease is still increasing. That will not be sufficient for authorities to convince them. For me, this would be this is really very convincing, especially if you see that on top the highly infectious variant that was circulating at the beginning of the mass vaccination campaign is now completely dominant. But that will not be sufficient for authorities or health authorities, because they will say, well, it will take time and demographics are all different and people behave different. We need to continue vaccination because we will reach that level where all of a sudden you will see that the infectivity rates will dramatically drop. So that criterion, unfortunately, they will not buy it. Another criterion would be, as I was saying, the increasing emergence of variants. I think I pointed out this already a number of times when you had the 1918 flu pandemic, where there was high infectivity rates. The virus circulated, had 3 waves. There were no variants whatsoever. And there are 2 publications on that. And they're also on my website, where autopsy samples have been taken from people who died during the flu pandemic, where the sequences have been analyzed, at least of 5 or 6 different samples. And no variants whatsoever, barely any differences in mutations could be found. So here we start the mass vaccination. We had already 3 variants before that, or maybe 4, don't know exactly. But since we started mass vaccination campaigns, we have now an increasing amount of variants. So the amount is dramatically increasing. That is one thing. The level of infectivity of these variants is also increasing, and then it all goes very, very fast, in fact. So, but then again, I don't think they will buy this as a criterion, because they will say, well, if you have high infectivity rates, you have a high number of mutations, and therefore also highly infectious mutants, etc. So, also the criterion that there will be an increasing lack of effect of infection prevention measures on the pandemic. I think that will definitely be the case.
even that will not be for the health authorities a criterion to say, well, you know, something else is going on here, because even with stringent measures, we barely have any impact. So frankly speaking, I think the only thing that will prove this hypothesis to be correct is two things. Is one, a rebound effect that, unfortunately, I must say, I'm not happy about this, not at all, is a rebound effect that I'm convinced of you will see in Israel, and also in the UK, and even quicker, faster in the UK than in Israel, for the reasons that I explained. That is one thing. And the second thing that will be a clear proof that something went wrong is when there is clear resistance to the vaccine. So the only problem with that is, before we will see this, because remember, the resistance in a vaccine can only really develop when in vaccinated people, when you have a large amount of them vaccinated. So by the time we will see this, any of these events, the rebound and the resistance, the vast majority of the population will already be vaccinated. And that is something that personally I find pretty dramatic, because in this way there is very few arguments left for people who do this study. And as you can see, these are very, very complex interactions. This is not just like, guys, we vaccinate, and the more we vaccinate, the closer we are to a complete relief of this pandemic. It's certainly not that easy, because right now, what is in people's mind is no longer this whole interplay between the virus and the immune system, the collective, the dynamics of this collective immunity that puts pressure on the viral ecosystem within the pandemic. None of this seems to be of interest. It's just all about vaccinating, and the end goal is to vaccinate as many people as possible, regardless of all these dynamics. Okay, with that, I think I'm gonna close this session. Tomorrow or the day thereafter, I will still spend a few words on natural immunity, because I think it's a very, very important compound. Don't forget that we talk about herd immunity as being, you know, antibodies, etc. The major component of herd immunity is definitely natural immunity. That is why when the pandemic starts and the virus comes in, 80% or even higher, depending on the composition and the demographics of the population, are protected. So this is thanks to natural immunity. So definitely I will make sure that I spend a few words on that as aspects as well. So many thanks for your attention. Bye-bye.